Yo, what is up, everyone? Parametric functions. We're gonna be going over the 2017 International Practice Exam BC Part A. This is found on AP Classroom. This one right here. I'm just gonna speed run through these, and with that, let's get right into it. Okay, so I made screenshots and I kind of put everything onto a doc. So, um, for time t from 0 to 8, the particle is moving in the xy plane. It has a position vector of x t y t. X is going to be sine 2t, and then y t is going to be t squared minus t. So parametric functions are just an x function and a y function dependent on time. Normally in a like a y equals mx plus b equation, y depends on x, right? In these equations in parametric, x depends on another variable, t. Y depends on another variable, t. It's often used for like referencing for like time. So like the position as x changes depends on time. The position of y changes depends on time as well. So you can just they're basically deconstructing a y equals mx plus b equation, y equals x equation, to depend on time. That's why you have a x function and a y function. Everything's the same. Derivative position is going to be velocity. Integral velocity is going to be distance. A little bit, just we're going to be one extra step. So let's get right into it. Find the speed of the particle at time t equals 2 seconds. Indicate units of measure. Speed is always going to be derivative of position. Here I'm giving my position. All I have to do is take the derivative of x and y at t equals 2 seconds, and then since it's speed, I'm going to have the velocity of x, I'm going to have velocity of y. But in order to get the combined speed, the entire speed of it, I'm going to find that horizontal vector. The hypotenuse, my bad, the hypotenuse vector. For that is going to give me the entire speed of it. Right, I can just draw it out right here. I have a little diagram going on right now. Right, I have an x. Oops. I have an x portion that's traveling. I have a y portion that's also traveling. Oh, a y portion that's also traveling as well. Right, to find the overall speed, hypotenuse. Okay, let's do this right now. T equals 2 seconds. So what I'm going to do is go into Desmos. I'm going to put in the x function, which is going to be sine 2t, the y function, t squared minus t, right, at t equals, what was that? 2 seconds. Right? What I want to do, or what I need to do is find the velocity, because these are my position functions, right? I can just simply in Desmos, d over dt. d over dt. Make sure I put these in parentheses as well. Okay. Now I have the velocity of x, I have the velocity of y. Now I need to find the hypotenuse, the speed, the entire speed. I find the entire speed by finding the hypotenuse. So square root of x squared. What is that going to be? X squared plus y squared. I just do that, but with these values now. What I can actually do, I can do this 2 different ways. I'm just in the more intuitive way. That squared plus 3 squared. Okay, this is going to be my answer. You can also call functions as well. Square root this, squared plus this quantity squared as well. I'm going to get the same answer as well. So my answer is going to be 3.272 meters per second. There we go. Next question. Let's get right into it. At time t equals 4 seconds, is the speed of the particle increasing or decreasing? So just like regular functions as well, as you learned in AB and throughout the whole year as well, determining if speed is increasing or decreasing is determined by is the acceleration positive or negative. Okay. Now, as I said before, this is going to be my speed, right? I need to find out, is this value at t equals 4? Is this value going to be positive or negative? Simply d over dt of this thing. It's going to be, this is going to be s prime t, derivative of speed. 2.16, positive, greater than 0, therefore increasing. See, not too bad. Okay, next one. Find the total distance the particle travels over the time interval from 0 to 5 seconds. Like we've done this whole year as well. The integral, the distance is the integral of the velocity. Okay. Right? This is my speed function. What do? Integral 0 to 5. This whole thing. When it's in terms of dt, not dx, dt. Dx will give you a different answer, 35. I want dt, that's going to be 22. Because I'm simply taking the integral of the speed. That's going to be my distance. I think the harder part here is trying to figure out what is that speed function. But speed is going to be my component of my x velocity and my y velocity. Okay, so letter D. At time t equals 8, the particle begins moving in a straight line. For t is greater than or equal to 8, the particle travels with the same velocity vector that had at t equals 8 seconds. Find the position of the particle at time t equals 10 seconds. So it's going to have, I need to find the position at, for the position, I'm going to have a x of t comma y of t. That's just how position is going to work. The way I'm going to do this is by finding the position it's at 8 for x and y. This is for 0 to 8. Find the position it is at the very end of 8 for x and y. Then I'm going to find the velocity at 8 seconds for x and y. Multiply by 2 seconds to find the distance it travels from time t equals 8 seconds to time t equals 10 seconds. Why? Because velocity times time equals distance. So position at 8 seconds. I'm going to delete these two. So for the x of t at 8, I'm going to write this down, is going to be this. Right? My y of 8 is going to be this. Right? Now I'm going to find the derivative of this at 8 seconds. It's going to be negative 1.9. Actually, let me make this better syntax. X of 8 plus x prime of 8 times 2. It's going to be my answer. So I have this function plus x prime of 8 is going to be negative 1.9 parentheses times 2. This is going to be my position at 10 seconds for x. Do the same thing for this one. Find the derivative of it is at 8, which gives me 15. So 56 at 8 plus 15 times 2, 86. So my answer is going to be negative 4, comma 86. Negative 4.11, comma 86. Not too bad.